All right, good morning, everybody. Okay, we're going to review chapter 14 first before we start chapter 15. So today is day 20. It's the end of the 10th week. So we have 6 more weeks after this. All right, first off, we have a question about the graphing technique. So let me just have to put it in my. Okay, we had a question about the graphing technique for using the software. All right, so here first off, we have these two equations here. We can graph the second one automatically because you have to put it in slope-intercept form. So to draw the graph, click on the graph, make it bigger. And then since we know it's a line, since we know this equation, y equals negative 3x plus 2 is a line, we're going to define a line. So the first point we're going to get to is the y-intercept, which is positive 2. 1, 2. Put a dot there. Click it, put a dot there. Then I follow the slope, which is down 3 over 1. And click it again. Just put it where it's supposed to go and click the dots. And submit. This, my graph is wrong. Oh, hold it. I think it's going to want me to graph the first one first. Okay, so let me write that one down. Yeah, 2x minus 4y equals negative 8. Y equals 3x plus 2. Okay, so for graphing, this one's already in the slope-intercept form, so I can just leave it the way it is. And this one, I have to solve for y. So I subtract 2x from both sides. That cancels that. So we have negative 4y equals negative 2x minus 8. Change the signs. 4y equals 2x plus 8. Divided by 4 each term. This can be simplified to 1 over 2. 8 divided by 4 is 2. All right, so I have both of my equations here. By looking at the slopes, since the slopes are different, I know that they're going to be one solution. They can't be parallel, it can't be, and they're not reciprocals of each other. So it's not perpendicular. So this is going to have one solution. So the way we graph these is the first equation. Okay, use the graph on the right-hand side. Okay. It's a linear equation. So the first graph, oops, hold it, let me clear. So the first graph was y equals 1/2 x plus 2. So put a dot on 2. 1, 2. And it's positive 1, 2. So it's up 1 over 2. That should be my first graph. Then the second graph, it is y-intercept is at 2. and it's -3 slope. So it's down 3 over 1. That's how you just click on where the points are. You have to be very, yeah, I don't like it's just that small. You can make them bigger on your computer by hitting the Control plus sign. You could increase the size of your screen by hitting Control and plus and Control minus to make it shrink back to normal. So yes, that's one option you can do there. So yeah, the procedure there again is when you're given two equations, line 1 and line 2, and you're using the graphing technique, put them both in slope-intercept form, plot the y-intercepts, and then from that point, follow the slopes. And then that plots the next one. So you have to, and you also remember you have to click on the graph. Since it's a line, you have to click on the line because it'll do the graphing for you. All you do is plot where the points are. Okay, well, we have this one up. Let's use these same equations. Since we know the intersection is at 0, 2, because they both cross at the y-intercept. Let's do the same equation now with the substitution and elimination method. So the first line is 2x minus 4. The second one is y equals -3x plus 2. We're using substitution here. The substitution method says you have to choose one line, one equation. I'm going to choose this one. Solve for a variable, which is already there. So anywhere I see a y in the other equation, I put -3x plus 2. So anywhere I see a y, I put a -3x plus 2 because that's what y equals. So we get 2x minus 4 times -3x plus 2 equals -8. All I did was put that in place of y. And solve for x. Since we have one equation with only one variable, we can now solve it. So the first thing we have to do is distribute. Get rid of the parentheses. Negative times negative is a positive. 4 times 3 is 12x. Negative times positive is a negative. 4 times 2 is 8. Equals -8. Once you get rid of parentheses, combine like terms. 2x plus 12x. They're both x's, so we add the coefficients. 2 plus 12 is 14. Minus 8, 14x. Minus 8 equals -8. Since all the x's on one side, get rid of the get rid of the 8. So add 8 to both sides. Got 14x equals 0, because -8 plus 8 is 0. Divide by 14, x equals 0. So that's the first step. That's the first phase. Since we have x, and we have it with solve for y here, now we plug in x in the second equation. Y equals -3 times 0 plus 2. Negative 3 times 0 is 0 plus 2, so y equals 2. So the point of intersection is at x is 0, y is 2. That's my solution. Remember, the solution is the point of intersection. All right, so that's using the substitution. Let's look at the elimination method. We use the same equation. Since we know what the answer is supposed to be, let's do the elimination method. So we have 2x minus 4y equals negative 8. Y equals negative 3x plus 2. For the elimination method to work, you have to have both equations in the standard form. Both equations have to be in this form, where x and y are on the same side. That one's okay. So we have to move the 3x over. So we add 3x on the second equation. Positive 3x, positive y, those equals 2. So my two equations are 2x minus 4y equals negative 8. 3x plus y equals 2. Put in standard form. Remember the next step? Wait, here now you have to choose a variable to eliminate. Do you want to get rid of the x's or the y's? Which is easier? You are on the right path. You're saying we're going to choose the y's because right now it's a 1 right here. The signs are different. The signs have to be opposite, but the numbers have to be the same in front of it. So since that's a 4, that's a 1, we have to multiply the second equation by 4. Gives 2x minus 4y equals negative 8. That's the first equation. 4 times 3 is 12x. Positive times positive is positive. 4 times 1 is 4. Y equals positive, positive is positive. 4 times 2 is 8. So now we have both equations in standard form, and we have a variable that has the same number but different signs. When we have that, what's our next step? We add the two lines. 2 plus 12 is 14. Negative 4 plus 4 cancels. Negative 8 plus 8 is 0. So we solve for x. Divide by 14. X is 0. Excuse me. So what we do now, since we have x equals 0, we go back to the original equations, and we can put it in either equation. It doesn't matter which one you put it into. So if we put in the second one, negative 3 times 0 is 0, so y equals 2. Let's put it in the first one, just for giggles. So we have 2x minus 4y equals -8. Because it doesn't matter which one you plug it into. So plug in 0 in for x. And solve for y. 2 times 0 is 0. Minus 4y equals -8. So the 0 is gone. There's a negative in front, so I change the signs. 4y equals 8. Divide both sides by 4. So y equals 2. X is 0, y is 2, and there's our solution. Let's do a couple more. I won't do the graphing because my graphs are horrible. So, but you should know how to do it. So for the graphing, solve for y, both equations, and plot the lines. Let's try this one. 6x minus 2y equals 24. Negative 3x plus y equals -12. Let's do substitution first. Remember, for substitution, we have to choose one equation, solve for a variable. So which one do you want to solve for? Which equation do you want to choose? Which one looks the easiest? Use the second equation, solve for which variable? Yeah, why? Because it's ready by itself. So for the second equation, we just have to add 3x to both sides. Those cancel, so we have y equals 3x minus 12. I chose the second equation, solve for y. Now we take that y and plug in 3x minus 12 anywhere we see a y in the first equation. Since we used line 2 in the first step, we used line 1 in the second step. So 6x minus y is 3x minus 12 equals 24. Get rid of the parentheses. Negative times positive is negative. 2 times 3 is 6x. Negative times negative is positive. 2 times 12 is 24. Combine like terms. 6 minus 6, they cancel. Since 24 equals 24, what does that tell us? There's no more variables. What does that tell us? Infinite solutions. Which means they're the same line. Let's look at it. To make the first number looks the same, So I have 6x minus 2y equals 24 on top. If I multiply the bottom one by -2, negative is a positive, 3 times 2 is 6. Negative times positive is a negative. 2 times 1 is 2y. Negative is a positive. 2 times 12 is 24. They're the same line. So if you ever end up with no more variables and the numbers equal each other, then they're the same line. What would happen? What would it be if we ended up with this? If we ended with that, no variables left, and the numbers do not equal. There's no solution. What does it mean about the lines? They're parallel. The only type of lines that don't have solutions are parallel lines because they never cross. So if you end up with no more variables and two different numbers, then the lines are parallel, you have no solutions. If you end up with no variables and the two numbers equal each other, then they're the same line, infinite solutions. Other than that, you'll have infinite solution. I mean, other than that, you have one solution. So let's look at elimination. Well, actually, this was elimination. I want to get, because elimination, you have it in standard form, check. You have to pick a variable to get rid of. I'm gonna get rid of the y's. So right now it's a positive one down here, it's a -2. So I have to multiply the bottom one by -2. If I do that, I get this. No, I have to multiply by a +2 because I need to have the same signs, opposite signs, same numbers. So it'd be -6, +2, -24. And if I add all these, I get 0 equals 0, which means same line. Let's look at some examples with fractions and decimals. Here's an important note. You could have gotten the first equation like this. We have x/3 plus y/2 equals 13/6. If you ever have this, what are the coefficients of x and y? The numbers in front, they're both 1. So now that means I could separate these. Because it's easy when you look at them this way. If they look like the x/3 plus y/2, then it looks more difficult. So you can separate them. So your first step, you have fractions and equal sign. What's your first step always? Get rid of the fractions, right? How do you do that? Yes. So find the LCD of both equations. The LCD of the first equation and the LCD of the second equation. So what's the LCD of the first equation? 6. How about the second? Very good. So I multiply each of the terms in the first equation by 6. And then each of the second equation by 4. So I find the LCD. I multiply the LCD to each term. Next step is reduce. Get rid of the fractions. So 3 goes into 6 twice. 2 goes into 6 3 times. 6 goes into 6 once. 2 goes into 4 twice. 4 goes into 4 once. 4 goes into 4 once. So this is what I have left. Now we have a system of equations. So what would be the easiest thing to do? We're using substitution, so we have to solve for one variable. Yeah, let's take the second one and solve for y. So we have to subtract 2x from both sides. We have negative y equals negative 2x minus 3. Change the signs. So you have y equals 2x plus 3. That's the second line. So I have y equals 2x plus 3. What do I do with that? What do I do with that? Right. Since we use the second equation in this first part, we take this and plug it inside the first equation. The line 1 is 2x plus 3y equals 13. So anywhere we see a y, we plug a 2x plus 3. Combine like terms. Hold it. Okay, yeah. Subtract 3 from both sides. So 4x equals 10. Divide by 4. X equals 5/2. This one?
So you put in the 2x plus $3 and the y, so what about the $3 and
Okay, we're this part here, we're only taking the second equation for this part. We're taking the second equation, solving for y. Okay, so we have moved the 2x over there. So we have negative y equals negative 2x minus 3. Change the signs. So this is our new second equation. Now we take this, since this is, we did that with second line, we go to the first line and plug in for y. So we have 2x plus 3y equals 13. Anywhere I see a y, I plug this into it. I see what you're saying. That's what I'm missing. I'm missing the coefficient. Good catch. Woo. Okay. My mistake. So we have 2x plus 3 times 2x plus 3. Very good catch. Very good catch. Yeah, because I missed that coefficient right there. Positive, positive, 3 times 2 is 6x. Positive, positive, 3 times 3 is 9. 2 plus 6 is 8x. Plus 9 equals 13. Subtract 9. 8x equals 4. Divide both sides by 8. 4 goes in 8 twice. So the x is 1/2. What do we do with that? Since we have x, we need to know what y is, right? Well, at the end of the first step, we have the equation for y. We use this equation right here. We'll come back to use it at the very end. So we know that y equals 2x plus 3. Plug in x is 1/2. The 2's cancel, so we have 1 plus 3. Y equals 4. So the point of intersection of my line is 1/2 4. That's my solution. All right. So let's look at the same equation using elimination. We're using 1/3x plus 1/2y equals 13/6. 1/2x minus 1/4y equals -3/4. Remember, for elimination, you have to be in standard form, which they are. That's good. We have fractions and equal sign. Get rid of the fractions. So multiply by the LCD, which is on top one is 6. And the bottom one is 4. We just did that. So we have 2x plus 3y equals 13. That's line 1. 2x minus y equals -3. Now, for elimination, we have to choose a variable to get rid of. We put it in standard form, there's standard form, great. So which variable do we get rid of? If we want to get rid of the x, what do we have to do? We want to get rid of the x, because they're both 2's, but they have to be different signs. If when we get rid of the 2, the x, we have to multiply the bottom one by -1. So we have 2x plus 3y equals 13. -2x, negative is a positive, positive y, negative is a positive, 3. Add them together. 2 minus 2 is 0. 3 plus 1 is 4y. 13 plus 3 is 16. Divide both sides by 4. And y equals 4. Because we used both lines in the first step, we can take this y equals 4 and put it in either one of the equations. It doesn't matter which one you put it into. Which one you want to put first or second? Let's put it in the first. So we put in 2x plus 3y equals 13. Anywhere I see a y, I put a 4. 3 times 4 equals 13. Three times 4 is 12. Subtract 12 from both sides. And divide by 2. So the point of intersection is 1/2 4. Is it okay with everybody so far? Even with fractions? It's a little bit more work, but it's the same process. You see, we get the same answers. 1/2 4, 1/2 4. All right, let's look at decimals. It'll be the last example, then we'll move on to chapter 15. Zero 0.5x plus 3.4y equals 13. 1.5x minus 2.6y equals -25. So how do you get rid of the decimals? How? You can't just move them because you have one equation. You can't change this one without changing all of them. Well, since all these decimals only have one on top, only have one place to move, each decimal place is times by 10. So for this first equation, we multiply everybody by 10. Same with the second. So each time you move a decimal to the right, that means you're multiplying by another 10. If it was 2 decimal places, it'd be 100. 3 would be 1,000. So basically, here's the way to look at it. For every 1 space you move to the right, that's another 0 after the 1. So we have 5x plus 34y equals 130. 15x minus 26y equals negative 250. Now we got it back to what we're used to. We're using substitution. So actually, would you use substitution? If I let you choose whatever method you want to on this, which one do you use? What's that? You would use substitution? I wouldn't. I use elimination. Because think about it. If you use substitution, you're going to have a lot of fractions. Possibly. Okay, let's use substitution. We'll do them both. Okay, so which line do you want to use and which variable do you want to choose? Solve for. Okay, we're going to choose line 1. And we're solving for what variable? We're going to solve for x. So we have to subtract the 34y from both sides. And then we divide by 5 each term. Five goes into 13 2 times with 3 left over. 5 goes into 30 6 times. So this is our line 1. We'll come back to use this to solve for x. So what do we plug this equation into? Since this is line 1, we have to use line 2 now. We have to use line 2. So anywhere C and X, we put this whole big equation in place of X. So 15 times negative 34 over 5 y plus 26 minus 26y equals negative 250. We have to distribute. 15 times negative 34 over 5 y plus 15 times 26 minus 26y equals negative 250. before you multiply, you reduce. 5 goes into 15 3 times. Nothing else cancels. So we have 3 times negative 34y plus 15 times 26 minus 26y equals negative 250. So what's my next step? Well, if you, yeah, distribute, if you get rid of the parentheses. We have to get rid of the parentheses. Let me rewrite this. I'm just rewriting it. So now we'll multiply, get rid of the parentheses. 3 times 4 is 12, carry the 1. 3 times 3 is 9, plus 1 is 10. Positive, positive is positive. 26 times 15, 630, 10, 13, 6 and 2, 390. Combine like terms. So we have 102 minus 26. 12 minus 6 is 6. 9 minus 2 is 7. So it's 76y plus 390 equals negative 250. Remember, we're solving for y. So we have to get rid of the 390. They're both negative, so we add them. 0 plus 0, 9 plus 5 is 14. 3 plus 2 plus 1 is 6. And divide by 76. Seven doesn't go into 64. So let's try for 7 times 10 is 760. 7 times 9 or 76 times 9. 63, 68. That's too big. So it has to be 76 times 8. 48, 56, 60. Well, since it doesn't simplify equally, let's just use it as that. If it was a perfect number, then we would just say, let's go ahead and use that. But since 76 times 8 is 608, then we have leftovers. So what do we do with this number? Yeah, since we solve for x over here, we plug this equation, this answer in place of that y. So from our first step, we found this number. So plug this in place of y. Negatives cancel, so it's positive. Five goes into six once with one left over. So 5 goes into 14 two times with 4 left over. 5 goes into 48 times. So 5 goes in there 128 times. We could simplify this even more. 2 goes into 76 38 times. 2 goes into 34 17 times. 2 goes into 38 19 times. 2 goes into 128 64 times. So we now have 64 times 17 over 19 plus 26. I'm sorry, I picked the wrong one. I felt, I don't know, these answers are gonna be so weird. I wouldn't have picked this example. So we have 64 times 17. 7 times 4 is 28. 42, 44. 8, 8. So it's 1088 over 19. Multiply this one by 19 over 19 to get a common denominator. 26 times 19. 23, 62, 494. 12, 18, 15. Wow. And that's your X value. Of course, it probably simplifies, but whoa. So the point of intersection is at I mean, 640 over 76, I can simplify that too. 2 goes in there 320. 2 goes in there 38 times. 2 goes in there 19 times. 2 goes in there 160. So the final answer is 1582 over 19. 160 over 19. Again, I'm so sorry. That's your final answer. That's an ugly one. Sorry. Okay. So that's it for chapter 14. We use the graphing method, substitution, elimination method. Now, chapter 15. It deals with what are called polynomials. Let's look at the words first. If it only has one term, it's called a monomial, because mono means one. Example is 3x or 5 or something else. It only has one term. If it has two terms, what's it called? Binomial. So we have a 2x plus 3 has two terms. Remember, a term is separated by plus, minus, or equals. But in this case, we're talking about the same, so it's plus, anything separated by plus or minus in this context. If it has three terms, so bi means two, what means three? Try. Four terms. Quadrinomial. Anything higher than that, usually anything after three, will simply, that's what we call what does poly mean? Many. Many terms. For example, at this point, we stopped counting the number of terms, but this is going to have 6 terms. We stopped talking about that. The way we define this one, we look for the highest exponent. Notice how the variables, the numbers on top get smaller until there's no exponent, our next coefficient. Because it's 5, 4, 3, 2. What number do you think is here? 1. That means this one has to have 0. If there's nothing there, it's an x to the 0. And we're going to learn about that in a minute. Anything to the 0 power is 1. So we look for the highest exponent. And we call it, that's called the degree. The degree of the polynomial is the highest exponent, the number up on top. So we would define that as polynomial of degree 5. That's how we would define that one. So it's polynomial, I mean, it has many terms, but the highest degree is 5. The reason being is that a binomial? It has 2 terms. It is a binomial, but it's also a polynomial of degree what? 7. It's the biggest exponent. So those are polynomials. Polynomials are anything that has a whole bunch of terms. The only rule that we have to learn first when we deal with polynomials combine like terms. Have we ever discussed that? Have we ever used it? Yeah, whenever we get rid of parentheses. Whenever you get rid of parentheses in equations, I said the first thing you do is combine like terms. So what does it mean, like terms? Yes. Doesn't have the degree. Wait, the degree, yes, they have to have the same degree. Have exact variable or variables. So combine these. Yeah. This term and this term are the same. So I add the coefficients. 7 plus 2 is 9x to the 5th. And then whatever I'm left with. Right. Why is that? Why is it that when we add 7x to the 5th plus 2x to the 5th, we get 9x to the 5th? Anybody guess? We studied this at the beginning of the semester. Remember, you can't do anything in math unless there's a rule says you can do it. And the rule we're using here is this one. What does that equal? What's that rule called? What's that property called? Distributive property. Distributive property takes whatever coefficient you have and multiplies it, distributes it to every term inside the parentheses. And order of operations says if you have special operations like parentheses or brackets and stuff, you do inside. Can we combine X and Y together? No, they're different. They're not like terms. That's why they say because we can't do anything here, we have to get rid of the parentheses. We do that by distributing. That's distribute, but we're more interested in going this way. AX plus AY. This is called factoring. What do they both have in common? So we take out the A, whatever's left goes inside the parentheses. So if we take out the A, what are we left with? X plus Y. So the same thing here. What do both of these have in common? They both have an X. So what goes inside the parenthesis? 7 plus 2 is 9. So we'll write this as 9x. The common convention is the numbers always go in front of the variables. So that's the reason we can combine the terms. When we add polynomials, we put them parentheses around them just in case there's a coefficient or there's a negative sign in front of there. So our first step, do we need the parenthesis in the first one? Is there anything in front of it? So we could just drop the parenthesis. Is there anything beside a 1? Is there a negative or a number in front of it? No. So what we're doing here, we're multiplying by +1, which means each term stays the same. Again, it's always the same. Whenever you get rid of the parentheses, the first thing you want to do is combine like terms. That's a general rule. So start with the largest exponent. The largest exponent you see is a 2. They both of those, they're the same terms, so we add them. 6 plus 4 is 10. So that takes care of those two. Are there any more exponents up there? No. So here we have x's. There's an x, there's x. They're both positive. This is a 1 right here. So 3 plus 1 is +4x. That takes care of those two guys. And then all we should have left are the constants. They're both positive. 5 plus 3 is 8. So there you have the combined simplified version of it. Combine these two. So we have coefficients now, so we can't just drop the parentheses, we have to distribute. So to get positive times positive is positive, 2 times 3 is 6, x to the 4th. Positive times positive is positive, 2 times 5 is 10. Positive is positive, 2 times 2 is 4. Positive is positive, 2 times 1 is 2. That takes care of the first one. +4 times 1 is +4, x to the 4th. Positive, 4 times 3 is 12. That got rid of the parentheses. So now look for the highest exponents. They're both 4s. So I combine their coefficients. 6 plus 4 is 10. That takes care of those. 3 is the next one. There's only one of those. It's a positive 10. There are no x squares, so x to the fourth is the next one. Or 4x is the next one. Then the constants. 2 plus 12 is 14. And there's your answer. Let's try with negative signs. Subtractions. Yeah, we have those two equations. All right, the first parenthesis, is there anything in front of it? So we just drop the parenthesis. Leave everything the same inside there. Now the second one has a negative in front of it. So it's actually -1. So we have to distribute that to everybody inside there. So negative times positive is negative. 1 times 2 is 2. Negative times positive is negative. 1 times 5 is 5. Negative is a positive. 2 and -3. All it does, if you just have a negative sign, all it does is change the signs inside the parenthesis. That's all it does. We got rid of the parentheses, so combine like terms. The highest exponent is a 4. So the first number is a -2x to the fourth. That's the only one. So the next after 4 is down to 3. Here's a 3, and there's a 3. 3 minus 5. 5 is bigger, so it's minus. 5 minus 3 is 2. So those takes care of those two. After 3 comes 2. There's a 2. So there's only one of those, so it's a -2x squared. Then after 2 x's, there's only 1x. 4x plus 2x. They're both positive, so we add the coefficients. Then the constants. -3 is -6. So there's your answer. And it doesn't matter how many groups you have, it's the same principle. Just get rid of the parentheses, combine like terms, and you're done. How about this? Simplify that one. 3xy, yes. Which one? This 6? So just the x's, right? So there's 4 of them here, and there's 2 of them here. This one? This one? They're both minus, so the common sign. 3 plus 3 is 6.
Oh.
All right. So what's the final answer? Everybody agree? That's the answer. Remember the rules of math. In the first day of class, we studied the commutative. What is the commutative property of multiplication? X times Y is equal to what? Y times X. Doesn't matter their order, as long as they're the same terms. So we have 3xy plus 5xy minus 7xy. I could rewrite these. Xy and yx are the same thing. 3 plus 5 is 8. Minus 7 is 1 xy or xy. Okay, so don't worry so much about the order. As long as they're the same, the letters have the same numbers on top and the same letters in that number, it's like terms. So far, so good. I know there's a lot of rules. That's why we start off slow in the beginning of the semester, is I want you all to memorize these rules. And we pick up pace. All right, so that does it for section 1. Let's look at section 2. Product and power rule. Before we begin here, when you add or subtract polynomials, you only change the coefficients. 3x plus 5x equals 8x. These never change. Only thing that changes is the number in front. When you multiply or divide, polynomials, you change both the coefficient and the exponents. So what exactly are exponents? What are they? What do they mean? Very good. Little number on top of the base. There. What does it represent? What does it mean? Very good. Tells you the number of times the base is multiplied to itself. Here's an example. The little number on top is the exponent. The number below it is the base. The number directly below it is the base. What it means is the base is multiplied to itself n times. It just makes it easier. Instead of having a whole bunch of the same numbers multiplied, you just make it into an exponent. So before we go any further, here's an example. What would that be? What was that? No. 6. Because remember, these are all multiplied together. This is 3 times x times 2. So what you have here is 3 times x times 2 times x times x. Because of the commutative property of multiplication, we can move these numbers around. Now the associative property. 3 times 2 is 6. Since they have the same numbers, I have 3 of them. It is x to the third. So whenever you have the same letters, or let's look at another example. If you multiply these together, what would you get? Okay, so we have 3 times 4 is 12, because 24, correct. What do we have next? How many x's do we have? How many y's? There's a y, there's a y, there's a y. How many z's? So there's your answer. You're just short each one by one. How about this one? What do you have to do first? Inside the parentheses. You only distribute if you can't do anything inside the parentheses. So we have 3xy in front. Are these the same terms? Yeah, x, y, z's. So 4 plus 2 is 6 x, y, z. 3 times 6 is 18. X times x is x squared. Y times y is y squared. And there's only one z. So there's your answer. As you can guess, exponents have their own rules. Let's go over those. The properties of exponents. The first one. If the bases are the same and you're multiplying together and they both have exponents, variables always have exponents. Always have an exponent. So you have the same bases and you multiply them together. What you're really doing is you're just going to add the exponents. Here's an example. Three squared means what? 3 times 3. 3 to the fourth means 3 times 3 times 3 times 3. How many threes do I have? They're all the same. I have 6 of them. I could do it that way, expanding them and counting them. Or, since I have the same base, I can add the exponents. So that's what that means. So if you have the same base, just add the exponents and you're multiplying them. If you have a number that's exponentiated or a variable that's exponentiated, raise to a power. If you have a power raised to a power, that's the same as multiplying the exponents. So this first one, that's called the product rule because it's the product of two terms. That's this one. So if you have a power raised to a power, or something like this, it's the same as multiplying the exponents. Let's see what this means. Since the outer exponent is 3, that means there's 3 of these guys. There's 3 of these, the 3 of the bases. So that's what that tells us. Because remember, the base is whatever's under that exponent. Now, what that means, in each of these parentheses, I have 3 times 3. Since they're all multiplied, I can get rid of the parentheses. They're all multiplied together. Since they're all the same, I just count how many I have, and that's my answer. So that's the long way of doing it. The shortcut is multiply the exponents. So it works. All right. The third property. If you have a product of 2 or more numbers inside the parenthesis raised to a power, then you distribute the power to both every term inside the parentheses. Only if it's multiplied or divided, not added or subtracted. For example, 3x to the third means 3x times 3x times 3x. So it's 3 times. Inside the parentheses, I have 3 times x. 3 times x. Since they're all multiplied, I can get rid of the parentheses. So far, so good. Now what I can do, because of commutativity, I can move all the numbers together and all the letters together. I have 3 of those, and I have 3 of those. That's the long way of doing it. Or I could have just distributed. Okay, let's look at both of the last two put together. Here's an example. What would this one be? Anybody have an answer yet? Don't do it the long way. I want you to use the rules we just talked about. Don't do it the long way. Use the rules we talked about. That's the whole reason I'm introducing them to you. What can you do with this outside exponent? It distributes to everybody inside there. So I have x squared to the fourth, y cubed to the fourth. Power to the power, what do? Multiply. 3 times 4 is 12. And there's your answer. All right, the fourth rule. Since it works for multiplication, the distributive property also works for division. What do you think that equals? You distribute that exponent to each term, top and bottom. X over 3 to the fourth. What that means is x over 3 times x over 3 times x over 3 times x over 3. Nothing cancels. So we have x times x times x times x. 3 times 3 times 3 times 3. Since they're multiplied, the same number, same bases. 3 to the fourth, or x to the fourth, 3 to the fourth. You just distribute it. It works. Okay, rule of thumb. If the number's easily calculated, work it out. Like if you had 3 squared, 3 to the power 2, that's the same thing as what? Three to the power 2 is what? 9. 3 times 3 is 9. 3 to the fourth. You have 3 times 3, 3 times 3. 9 times 9, this is 81. So you'll be expected, if it's an easy number, you'll be expected to work it out. But if you had something like 7 to the 35th, just leave it as 7 to the 35th. Another way of looking at fractions. In rule 4, the top and bottom were different. Now the top and bottom have the same base, different exponents. For this first one, we're saying that the top exponent is bigger than the bottom. So if the top's bigger than the bottom, you subtract the exponents, the top minus the bottom. Three times three times three, there's 5 threes on top, 2 threes on the bottom. The rule of division is if they're the same, you remove them, which is why it's subtraction. So what I have left is 3 to the 3, which is what we had earlier. Since 5 is bigger on top, the exponent's top is bigger than the bottom, 5 minus 2. Okay, so that's if the top number is bigger than the bottom. What if the bottom number is bigger than the top? Then you subtract where the bigger one is. If the bigger number is on the bottom, then you subtract down there. Three squared over 3 to the 5th. 3 times 3. 3 times 3 times 3 times 3. The 3's cancel. So what are we left with? What are we left with? Remember, there's a dividing line here. Yeah, because 3 goes in 3 once. So on top we have 1 times 1, which is 1. 3/3. Which is the same thing what the rule says. Since the 5 is bigger on the bottom, I'll subtract there. Or it would be 1 over 27 equals 1 over 27. 3 times 3 times 3. So rule 6 also now introduces us to another concept. What if the bottom number is bigger than the top? And if we subtracted on top, what would happen? You get a negative answer. It'll be whatever the negative answer is. So let's see. So I have 2 minus 5. So it's 3 to the negative 3. But we know from the rule 6, what does this become? We know from the rule 6, what is this one? If the bottom is bigger than the top, what does this become? This becomes a fraction. It becomes 1 over m minus n. So rule 7 says this. If you have a negative exponent, it doesn't make the answer negative, it just changes the location. The negative exponent simply changes the location of the number. If the negative is on top, remember this is on top, this is over 1. I put it to the bottom and drop the negative. If it's on the bottom, I bring it on top, drop the negative. That's all you do with a negative exponent. Change the location of it and drop the negative. So how would you write that one? Where's the negative exponent? Does it belong to the 3? Are there parentheses? No. The negative exponent only belongs to the base. So it would be 3 over x squared. And if you have a negative x on the bottom, or a negative exponent on the bottom, there's the constant, the other terms don't get influenced by it. How would you write that one? Does x squared change? Does y to the negative 3 change? Well, yeah, because it's negative exponent. So the x and the z don't move. The only thing that moves is the y because it has a negative exponent. Okay, so far so good. So that's the rule of negative exponents. You will never end up an answer with a negative exponent. If your final answer looks like this, you have to write it so it's a positive exponent. No. Your answer never have a negative exponent. If you end up with a negative exponent in the final answer, then fix it so it's not negative anymore. All right. Next rule. 8. X is equal to x to the first. With 3 to the first is, how many 3s do I have? Is just 1. So it's the same thing. Why is that important? What is x squared? X times x. But what rule tells us we can go from here to there? We know x squared means the same base twice, but how can we go from here to there? What rule says that? We have the same bases, we're multiplying. So what rule kind of looks like that? Don't look at the board, look at your notes. What rule has the same bases multiplied to each other? Okay, the first rule, if you have the same bases, what do you do with the exponents? What's rule one tell you? Look at your notes. What does rule one tell you? Anybody? Why are we taking notes if they mean nothing? What do you do in rule one? What does it tell you to do? Add the exponents. Well, from rule 8, what are the exponents to these? Since they're the same bases, we add the exponents. That's where that came from. How about x to the 0? Why? Why is it 1? No, but I see what you're saying, but no. But I understand what you're saying. But I didn't think about it, but no, that's not. No, I'll show you a better answer. It has to do with both of these terms. Let's look at this. What do we know equals 1 for sure? Besides the number 1, what equals 1 all the time? A number divided by itself. The number could be any size. If you have exponents and the same bases divided by each other, then we subtract the exponents. N minus n. What is n minus n? 0. So there's the reason why. Anything to the 0 power equals 1. Work that out for me. Let's combine these rules. I just put that up there. Actually, you were going for both of those. Because x squared means x times x. They both have, since there's nothing there, this rule says if there's nothing there, it's a 1. So that because rule 1 says we have the same bases, you multiplied, add the exponents.
Oh.
This one says anything to the 0 power is 1. And this is the reason why. 1 is anything divided by itself. Anything divided by itself. So if you have exponents, the rule of 6 says that you could subtract the exponents, n minus n is 0. Okay, so here's an example. So what does the first one become? 3x to the cubed. What's the rule tell us to do about that? Distribute. Get rid of the parentheses, and same thing with the other one. Three times 3 times 3 is 27. What is 4 to the 4th? That's 4 times 4. 4 to the 4th. Yeah, it says 4 times 4 times 4 times 4. It's 256. You can do 16 times 16. Or there's an easier way. In this case, 4 is the same thing as what? 4 is made up of what? 2 times 2, right? So it's 2 squared to the 4th power. What do you do with these guys? Power to a power, you do what? Multiply. You add if you have the same bases. So these power to a power, you multiply. 2 is a lot easier. 2, 4, 8, 16, 32, 64, 128, 256. You just multiply the numbers by 2. Makes it much easier to do. So if you can rewrite this number to an easier one. So it's 27 times 256, x to the what? If the same bases, different exponents, you add the exponents. You only multiply when you have a power to a power. When you have a power to a power, you multiply. When you have the same bases multiplied, you add the exponents. Again, have your rules on a separate sheet next to you when you do these things. Okay, here's another example. 5 times 2, x squared, y cubed, z to the 5th, all that to the 4th. Okay, so what'd you get so far? Does the 5 get a 4 also? No, because it's outside the parentheses. We can't do anything inside the parentheses, so we have to distribute this 4 to everybody inside there. So we have times 2 to the 4th. What's the x going to be? You have a power to a power. What do you do there? What's the rule for power to a power? You multiply. So 2 times 4 is 8. 3 times 4 is 12. 5 times 4 is 20. Two to the 4th we can do. 2 times 2 is 4, times 2 is 8, times 2 is 16. Five times 16 is 80. There's your answer. Because, oh, that's a very good question. Why can you not distribute? Well, first off, yeah, okay, I'm gonna go with yours now. I'm gonna discuss. Can you distribute 5 to inside the parentheses? No, because what does this 4 up here mean? Remember, order of operations is multiplication or exponents. Which one's higher in priority? Exponents. So you have to do exponents first. You have to get rid of the parentheses first, and then you can multiply by 5. So that's why you couldn't do that. And 2, you can't distribute because inside here there's no plus or minus. The only thing you were able, if that 4 wasn't there, the only thing you could be able to do is multiply 5 times 2. There's a difference between these. There's a difference between there. Since this is just one big number multiplied together, all you can do is multiply like terms. 5 times 2 is 10. Remember, the distributive property has a plus or minus inside here. That's when you could distribute. So that's when you have to go through all those. Okay. I'm going to put down 4 examples here. Work all 4 of those out. What'd you get for the first one? Anybody? It's -9. Because the 2 only belongs to that 3. So we have -3 times 3, which is -9. This one, the parenthesis belongs to that 2, so it's -3 times -3. Negative is a positive, 3 times 3, so the answer is +9. Likewise with this one, the -3 times 3 times 3, so it's -27. -3, -3, -3, because the parentheses is under that. Negative times negative is positive, times negative is a negative. 3 times 3 is 27. So it matters if there are parentheses or not, and negatives or not. Because in reality, what's happening here is this. This negative is actually a -1 times 3 squared. Order of operations says do exponents first. 3 times 3 is 9. -1 times 9 is -9. If you have a negative inside a parenthesis and the exponent is even, that number will always be positive. If you have a negative inside a parentheses and it's an odd exponent, it'll always be negative. All right, do those 3. Okay, in this first equation, order of operations, you have to do inside parentheses. Can you do parentheses? No. So I have to get rid of the parentheses. This 2 distributes to both top and bottom. So it's 2 squared over 3 squared times 2 to the 3rd. Okay, so this is over 1. The same bases, you can add the exponents. 2 plus 3 is 5 over 3 squared. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 3 times 3 is 9. There's that one. That's the first one. All right, now the middle one. Since it's all inside the parentheses raised to the power 2, this 2 goes to each term, each number. So we have 5 to the 2nd, x to the 3rd to the 2nd, and 3 to the 2nd. 5 times 5 is 25. A power to a power you multiply. 3 times 2 is 6. 3 times 3 is 9. As we have that one. And likewise, this 4 goes to both of those terms inside the parenthesis. So it's 1 to the 4th over 5 to the 4th times this 2 goes to both of those. 2 squared x squared. Again, that's over 1. One to the 4th, 1 times 1 times 1 is 1, so that nothing, it's just 1. So on top we have 2 squared x squared 5 to the 4th. 2 squared is 4. 5 to the 4th is 5 times 5 is 25. 25 times 25 is 625. There's that answer. Remember, if the exponents are small, then go ahead and work it out. Brain's hurting? Okay, that's the end of section 2. We have 8 sections in chapter 15. Actually, we've done one of them already. Not the next one, the one after that, the quotient one. We'll just do a little bit more rules. Oh, one thing I want to make sure, because notice the question we had earlier is, can I distribute? But because I had a plus or minus, you couldn't. This one, since it's multiplied together, you distribute both of those. So it's 3 squared x squared. For this one, it does not equal x squared plus 3 squared. You cannot distribute. You cannot distribute if it has a plus or minus inside the parentheses. So this is wrong. What this means is the whole parentheses is multiplied to itself. Since it's raised to the power 2, this whole base is multiplied to itself twice. So do not distribute if it has a plus or minus. Do not distribute, or this stuff. And we'll talk about that on Monday. All right, everybody.